Let's start off with the question. What is one thing that humans are known for? You're right. Humans are known for being an expansionist species. If you'd answered anything else, it probably is another good answer that fits the definition of a human. Anyways, humans have conquered almost every piece of land in the known world, so naturally we'd expand upwards to the stars. But how we do that is still a question we're trying to answer. Fortunately, we have a big and shiny sphere that hovers above us in the night sky. The other world that blots out the sun from the sky during some days and turns from chalk white to crimson red on other days. That is the moon. Hello, and welcome to another episode of Let's Talk About, the podcast where we delve into a wide range of topics spanning from current crises, finance, science, and many other things. I'm your host, the host. Today, we'll be talking about how humanity's spacefaring future lies on the moon. I'm sure that some of you, if not most of you, have heard about us attempting to send people to Mars. It is a big and expensive hurdle. According to a document which NASA released concerning the cost of a manned mission to Mars, quote unquote, the NASA Authorization Act of 2010 tasked the National Assembly of Sciences to perform a human spaceflight study to review the goals, core capabilities, and directions of human spaceflight. Costs for a Mars mission were assessed during the Design Reference Architecture 5, or DRA 5, which is a long surface stay conjunction mission. The NRC found that the scale of the government investment required to send humans to Mars is, to a rough order of magnitude, equivalent to 2 or 4 times the US investment in the ISS, which amounted roughly to 150 billion, including launch costs. This means that the cost of a long human stay on Mars is estimated at roughly 300 to 600 billion. And just so you know, there are several estimates from several sources that have been mentioned in the document, with prices largely ranging in the hundreds of billions, with a few estimating in the tens of billions. Still, that is incredibly expensive. One way we can cut costs is to reduce the amount of fuel needed to get into geosynchronous orbit, which is a fancier way of saying an orbit around the Earth. Launching a payload from Earth requires a lot of engines, fuel, and separation stages. Now, there are 2 ways to solve this issue. We could spend months, years, and millions and billions of dollars creating more efficient rockets, or we could launch from a region of lower gravity, like the moon. The moon has roughly 1/6 of Earth's gravity, which means that you'd weigh 1/6 of what you weigh now, which gives us 2 benefits. If you were looking to lose weight, the moon is a possible solution. And due to the reduced gravity of the moon, we can use less fuel for an increased amount of payload, thereby making missions such as the Mars mission a lot easier. Another thing that I had not mentioned earlier was the possibility of lunar ice at the moon's south pole. You might have heard about India's Chandrayaan 3 mission landing on the moon. According to a CNBC article about the Chandrayaan 3 mission, one of its main missions was to search for ice, as in water ice, on the moon's south pole. Now, if there is ice, it could be melted into water, and water can be used as rocket fuel. If you're confused, which you obviously are, let me explain. You've learned in science class that water is also known as H2O, which means a water molecule consists of 2 hydrogen atoms and 1 oxygen atom. Now, chemical rocket engines require chemical reactions to propel the rocket. And chemical engines use a type of fuel called liquid bipropellant rocket fuels. Here's how it works. Quoting from an article published on the website known as Aerospace America, cryogenic liquid bipropellant, a chemical rocket fuel, is composed of a fuel and an oxidizer. The fuel can be many things: hydrogen, methane, or kerosene, even paraffin or powdered aluminum. The oxidizer is nearly always liquid oxygen, or LOX. Usually 70 to 80% of the mass of the rocket propellant before takeoff is LOX. So if Chandrayaan is successful in finding lunar ice at the moon's south poles, this could potentially allow us to create rocket fuel on the moon. Mining on Earth is incredibly detrimental to the environment. Since the recent technological revolution, we needed more semiconductors, lithium, and other rare earth metals and elements crucial to make our tech. According to an article on the Harvard International Review, there are two methods of REE mining. REEs stand for rare earth elements. The first method removes the topsoil and creates a leaching pond where they add chemicals to the earth to separate the metals. Then the chemicals dissolve the REEs, which can be later concentrated and extracted. If the leaching ponds are not contained, then the chemicals can infect waterways and negatively infect ecosystems. Another way you could mine for REEs is to drill into the earth with PVC pipes and inject chemicals to make a leaching pond. This method has the same effects as the former, including that sometimes the PVC pipe that is used is abandoned in areas that are never cleaned up. On the moon, however, there are no ecosystems to be destroyed, and there could be more metals to mine on the moon than on Earth. According to an article on the NASA website about the metal content of the moon, states that substantial evidence points to the moon as the product of a collision between a Mars-sized protoplanet and the young Earth, forming from the gravitational collapse of the remaining cloud debris. Consequently, the moon's bulk chemical composition closely resembles that of Earth. Look in detail at the moon's chemical composition, however, that story turns murky. For example, in the bright plains of the moon's surface, called the lunar highlands, rocks contain smaller amounts of metal-bearing minerals relative to Earth. That finding may be explained if Earth fully differentiated into a core, mantle, and crust before the impact, leaving the moon largely metal poor. But to the moon's Maria, the large darker plains, and the metal abundance becomes richer than that of many rocks on Earth. So, mining on the moon would be a great way to get materials for construction, technological development, and other things. Plus, this is a great way to generate income for a colony on the moon, or better yet, establish an economy on the moon. Sadly, there are many challenges we face on getting to the moon. For example, the price to get things to the moon is incredibly expensive. NASA plans to send people to the moon again with the Artemis program in the year 2024 to 2025. However, NASA's Inspector General has estimated that the mission will cost around 93 billion US dollars between the years 2012 and 2025, costing 41 billion US dollars for a single launch, according to a PBS article about the Artemis mission. And this isn't a long-term stay. If there are people inside the colony, then we'd either need to ship oxygen or get oxygen from splitting lunar water. Since there's no atmosphere protecting the moon from solar radiation, there would be an increased risk of cancer. Nevertheless, getting a permanent base on the moon would be great, because moon mining could establish a new economy and additional wealth to the global economy, as well as making other planets easier to colonize. This is why the moon is a stepping stone in our future. We hope you've enjoyed today's episode. If you'd like to give us the topic of the next episode, email us at letustalkabout@outlook.com. Don't forget to check out our website, which the link will be in the description. The link to all articles we use as sources will be mentioned in the description as well. We hope you have a great day. This is the host, signing off. Goodbye.